All right. The next two problems involve changing from a rectangular HI plus VJ form into a polar R theta form. And so far we've done the other way around. We started at polar, gone back to rectangular. It was really straightforward, right? H equals R cosine theta, V equals R sine theta. Calculator evaluates, of course, everything's great and it's easy and life is good. Going the other way around is a little bit more challenging. Okay? And the main difficulty people have is that we have to find theta in two parts. And the reason why, let me go to the second page and go them side by side here. Depending on what quadrant you're in, what we're doing here, if we do the V over H, absolute value of V over H, V is this, H is this, right? And V is this, and H is this. And V is this, and H is this, and V is this, and H is this. Each case we're basically creating a right triangle out of this, right? And with right triangle trigonometry, the angle that we're here in the corner, this little guy here, this little guy here, this little guy here, that little guy there, is just an acute angle within that triangle, right? V is the opposite side, H is the adjacent side. V opposite H adjacent. V opposite H adjacent. V opposite H adjacent. Opposite adjacent is tangent, right? So we do inverse tangent of V over H, that gets us the measure of that angle. Alright? That angle, if I were doing absolute value of V over H, is always going to be between 0 and 90 degrees. Alright, if I'm in the unit circle world, 0 degrees is here, 90 degrees is up here. If I get an angle between 0 and 90, I'm in the first quadrant. So if I get alpha and I'm in the first quadrant, theta and alpha are the same number. Because I'm getting an answer between 0 and 90, which is what I'm looking for, right? If I'm looking for an answer in the second quadrant, I'm looking for something between 90 and 180, right? So imagine that alpha is always right here. It's always measured from the vector to the x-axis. Alpha lives right there. But what I actually want to know is theta, which lives right here. We always measure theta from 0 counterclockwise to the vector. Notice that theta and alpha add up to 180, right? In that scenario, if we're in the second quadrant, alpha, the angle in the vector, and theta, the angle to the vector, add up to 180. They make a straight line. Well, that means that theta, the angle I care about, is 180 minus alpha. Okay? I've already carried out all the calculations for you. You just have to do the right thing. So basically the technique of changing from rectangular to polar form is this. Step 1, identify H and V. H is the x-coordinate, V is the y-coordinate of the rectangular form. Alright? Square root of squares added together, basically the Pythagorean theorem. Inverse tangent V over H, positive V over H, absolute value. H squared and V squared, positive. So step 1, everything's positive. Step 2, everything's positive. Step 3, determine by whatever quadrant you're in. So let me show you an example. Let's look at example 5 just to see this. We'll see this process go all the way through. I'm going to rearrange some pages here. Let's see. All right. Negative 5i minus 3j to polar form. We're going to use that technique right there to do this. And I'm going to show you step by step how to do it. Okay? And if you believe in the technique and you do it correctly, you're going to get the right answer. Step 1. Polar magnitude. R equals the square root of. What's 5 squared? 25. What's 3 squared? 9. No. It's negative 5 and negative 3, but when you square things, you get positives anyway, right? So don't think about the negatives in step 1. Just square the numbers you're looking at, get what you get. That's going to be the square root of 34, which is perfectly fine. If you leave the square root of 34, that's fine. If you'd rather evaluate it to a decimal, square root 34, it comes out to 5.83. Okay, so my goal here is to make a, where's that at? There it is. My goal is to make this polar form happen. Jeez. There we go. So what I'm looking for is something angle something, right? That's how I find the number in front. Okay, so again, looking at the structure, R is the number that goes right there. R is what step 1 is finding for us. So we've already found half the answer by doing step 1. All right? Step 2. So that was step 1. We'll do that in blue. Step 2 we'll do in green. Find the reference angle. So again, every one of these vectors live in some quadrant, and each one of them makes a right triangle with a little acute angle down there in the corner, right? The reference angle alpha. So for step 2, alpha is going to be the inverse tangent of v over h. Now I have absolute value bars in my process. What do absolute value bars do?
Make it positive.
Make it positive. So just make everything positive. Don't worry about the absolute value bars. Just know mentally it's supposed to be positive numbers. So v over h, second over first, 3 over 5. And again, I went back to the vector. All right, so I got the numbers to go here. I got the numbers to go here. Every time I'm going back to the vector to figure out these values that I'm looking for. Anybody off the top of their head know what inverse tangent of 3/5 is? My calculator sure does. Inverse tangent, so notice second tan, 3 divided by 5 in parentheses equals. My calculus says it's 30.96 degrees. So alpha is 30.96 degrees. That's what step 2 is. That is not what I'm looking for this, but that's going to help me find that, okay? Because again, what alpha does is it tells me how to find theta based on alpha. It's going to be one of these 4 relationships. I have to pick the right one based on the quadrant. So that's all step 2 is. You find that reference angle measure, your calculator calculates it for you. Inverse tangent, v over h, type it in, you get some number between 0 and 90. Step 3, we're going to do that in red. Determine theta by the quadrant. That tells me I need to figure out what quadrant I'm in. Alright, so think about quadrants. That's like an x coordinate, that's like a y coordinate. -5 takes me which direction?
Left.
And -3 takes me?
Down.
My vector is down here somewhere, right? I can be exactly where it is. 1, 2, 3, 4, 5, 1, 2, 3. It goes right there. I want to be exactly right. My goal, though, is the quadrant. I need to know what quadrant we're in. First quadrant, second quadrant, third quadrant, fourth quadrant. Those are the 4 quadrants. Start here and go counterclockwise. All right? We're in the third quadrant. So for step 3, I'm going to identify the quadrant I'm in. And then I'm going to look at my list of things to see what my relationship is between theta and alpha. In the third quadrant, my relationship is theta. What I care about is equal to 180 minus alpha that I just found. Oh, sorry, plus alpha. Sorry. Should use my eyes more. 180 plus alpha. Third quadrant. Plus. All right. 180 plus 30.96 just happens to equal 210.96 degrees. R found, theta found, answer. These answers are checkable. This and this are supposed to be the same vector, right? If I do r cosine of that, I should get h. If I do r sine of that, I should get v, right? Will I get exactly h or v? No, because I rounded things, right? But I should get pretty close to -5, -3. 5.83 times cosine of 210.96 comes out to -4.99938. Almost -5, right? 5.83 times sine of 210.96 comes out to -2.999182482. Almost 3, right? -3. If I had gotten the wrong quadrant, right? Watch this. If I had said 5.83 times sine of 30.96, that's in the first quadrant instead of the third quadrant, right? Notice it's positive 2.999182842. Get the wrong sign on it. All that putting in the other quadrant does is it gets you the correct sign on things. So it's important to get in the right quadrant. But again, the quadrant's based on the ordered pair object. Negative, negative takes me left and down third quadrant, so that's how I find it, theta from alpha. Every time alpha is found using inverse tangent, theta is found using one of these 4 facts based on the quadrant you're in. That's how you do it. It becomes quicker as you do it. All right, you practice it, get good at it, you get quick at it. It doesn't take very long to do this at all, but again, it's very piece by piece. Each piece has a specific job. Let each piece do its job, then move on to the next step.